The International Space Station is a state-of-the-art research laboratory that allows scientific research to be performed in the microgravity of space. Research in this unique microgravity environment is advancing our knowledge of biology, chemistry, physics, and physiology. Scientists from all over the world are using facilities on this high-flying international laboratory that is packed with some of the most sophisticated technologies ever designed. Space station research brings new discoveries, furthers technology development, expands our limits of exploration, and improves our way of life on Earth. Hi, my name is Jane Jitt Gensler, and I work on the International Space Station program at the NASA Johnson Space Center. In my day-to-day work, I get to work with scientists and engineers who actually build hardware that flies to the International Space Station. I also get to work on outreach projects. Today, I'm at the Ames Research Center out in California, and with me, I have Dr. Sanjoy Som, who's going to be launching a really cool experiment to the International Space Station later on this year. So, Sanjoy, why don't you introduce yourself?
Sure can do. Welcome to Ames, Jane. Hi everyone, my name is Sanjoy, and I have multiple jobs here at NASA Ames. On the one side, I'm a scientist studying life in extreme environments. On the other end, I'm an engineer working for the Fruit Fly Lab project, which is launching this fall to the International Space Station. Myself and my colleague Julie are two systems engineers for Fruit Fly Lab. That means we're in charge of making sure that the science requirements are translated to the engineering hardware, and that the engineering hardware is then qualified for flight to the International Space Station.
Wow, that sounds really cool.
It's fascinating work. Hi everyone, welcome to the actual Fruit Fly Lab within the science laboratories at NASA Ames Research Center. This is my colleague, Dr. Hosamani. He is a scientist with the Fruit Fly Lab mission. It is very important for us engineers to talk to the scientists regularly to make sure that their hypotheses that they are testing on the space station is captured by my engineering hardware. So I just want to emphasize that when you're in school, it's not only about the academics, right? Learn how to communicate with your colleagues, because that's going to be extremely important in your professional career. So now we're going to show you the hardware that Dr. Hosamani's flies are going to be living in, and that we're launching this fall to the International Space Station. Come check it out. Okay, so now we're still in the Fruit Fly Lab, and we're going to talk about the hardware that is used to satisfy the scientific requirements that were given to us by Dr. Hosamani and his team. Now, before we do that, let's talk a little bit about the International Space Station and where we'll be located. The location in the International Space Station within which our observation system needs to fit in has already been given to us. That means we cannot build it in any kind of shape or form. It needs to fit inside slots that already exist on the space station. These slots are the same on the centrifuge, which is right next to where we're going to be living. So the flies go into the observation system. The observation system goes into what's called a biorack, in which they will sit in space. This is in microgravity. Right next to it is a centrifuge that will house also the observation unit and the cassettes, and the whole thing will spin. The reason it's spinning is that it's going to impose an artificial gravity, like we have on Earth, to the flies. Okay, so now that we know how we're housed on the International Space Station, let's talk about the constraints for our hardware. The first constraint is that we have to reuse the house of the flies. This cassette is where the flies will be living for the duration of their mission in space. This cassette was flown on the space shuttle in 2006, and one of the constraints was that you need to reuse the same hardware. This blue tray you find in here is actually the food for the flies, and that's important for an additional constraint we'll talk about in a bit. So we need to build a unit that houses this same cassette on the International Space Station, satisfying one of the scientific requirements given to us by the team. That is, they want to monitor the behavior of the flies in space. That means we need a camera. And if you put this inside a box with a camera, it's not going to work very well. Why? Because there are no lights. So we want to put lights in there as well, but let's be smart about it. Let's install lights that simulate the day-night cycles that the fly would live through if they were on Earth. That's called the circadian cycle. Now, if you just use the big bulb, that would stress them out, and stress is not good. Otherwise, they don't behave the same way as they would on Earth. So how do we put this cassette inside a box with a camera and with a light? This box then needs to fit inside the racks that are already existing on the International Space Station. So the important dimensions are, your box cannot be much wider than this, and probably only 3 times as tall as this cassette. So another important constraint when working with biological specimens in space is temperature. Flies operate best between 20 and 25 degrees Celsius, and if you leave your lights and camera on for too long, it's going to get too hot. So we need to think carefully about what is the timing of the cameras and the lights such that all the scientific requirements are met and our flies are still alive. Now, if it gets too hot, one way to dissipate away that heat is using fans. So we could put one big powerful fan that removes all the heat, and that would be good. But the problem is that we are constrained by the amount of power we can use. That's because the International Space Station uses solar panels, and there's a lot of really exciting science and engineering work that's done on the station. All of them want power. So there's only a specific amount that is dedicated to us. So we can't use a lot. So you have to be very judicious in how the power is used. One constraint that we have on the space station is the astronaut time. They have a bunch of experiments that they're working on, so they only have a small amount of time dedicated to ours. And where they're going to be really helpful for us is to change the food for the flies, because the food in this cassette is not enough to sustain the flies for the entire duration of the mission. So what we have done is built a piece of hardware like this. It's called a food changeout platform, which is specifically designed for the astronauts to change the food here quickly and efficiently. The way it works is that you put the cassette inside this changeout platform like so, and then a real changeout platform would have the new fly cassette in here. The new food in here. And then the astronauts will use this bar and push in the new food and pushing out the old food. This old food contains larvae of the flies, which we can then preserve for scientific examination back here on Earth. Okay, so now that the astronauts have the new food inside the cassette, they need to be able to reinstall that quickly inside the observation system. So the observation system needs to have a door that opens efficiently, that we can put the cassette in, close it, and then you're done. So no screws, no screwdrivers, nothing. So that's an important constraint, astronaut time. Okay, now you know all our constraints that we need to operate under in order to satisfy all the scientific requirements into our engineering hardware. It is now your turn to design it.
Now that you've had a chance to design your fruit fly observation system, let's see how that compares to what the engineers put together that's going to fly onto the International Space Station later this year.
All right, so here's what we did. Let's start with our cassette. Remember, that's where the flies live, and we have our food tray inside. And like any engineering drawing, I need my axes. Excellent. And then we were constrained by the shape of the observation system, such that this can go inside, within which the house of the flies is inserted. Inside it, we're going to have our camera up there with a fisheye lens, such that the fisheye lens can capture the entire resolution, the entire space of where the flies are living. Now, in terms of lighting, remember I told you it was a bit tricky because we don't want to put bulbs that shine brightly onto the flies. So the way that we did it, let me just redraw that same image up there, with the cassette here, is that we actually enclosed the bulbs on the underside so that they shine upwards, and put a mirror up here that then diffuses the light uniformly onto the flies. So that took quite a bit of trial and error. And also we have the camera there that's then filming the flies. And so in order to have the unit not warm up, we actually used software to integrate with the hardware that turns on and off the cameras at times such that it doesn't get too hot in that. And that took extensive lab trial as well to see how long we can record before it gets too hot. The final constraint was to make it efficient and quick for the astronauts to remove the cassette, change the food, and put it back. Do you think we went with a solution that involved screwdrivers and a bunch of screws? No, we went with something little. I'm going to redraw the same thing in 3 dimensions to give you a better idea of what we did. Inside, we have the cassette. And so what we did is install hinges with our door and a little clip there, on the side of which we installed a stiff rubber band that's then fixed at the end, such that if you want to close the unit, you close the door, insert the rubber band, your observation system is shut. To open it, just unhook the rubber band and the thing opens, and then the cassette can come straight out and we can change the food. This is an efficient and simple way, and most importantly, safe way for the astronauts to use our system. Now, we have completed all our testing, and our experiments can then operate safely on the International Space Station, is safe for the astronauts, can survive the shake of the launch vehicle as well as the return, and will guarantee the maximum science from the scientific requirements that were given to us by the scientists. We're almost done with all our testing, we're really excited about the mission, and we're launching this fall. Oh my goodness, this is so cool.
Hi, welcome back. This is my favorite part of the interview, where we get to learn a little bit more about Sanjoy. Now, Sanjoy, can you please tell us about your education background?
Sure. So I went to school in Europe, and in high school I've always been really passionate about space exploration, but I was not very good at math and physics, but I really enjoyed it. So I took my courage and then applied to engineering school in America, and I ended up at the Florida Institute of Technology, which is a small school down in Florida, right by the Kennedy Space Center, which is really exciting. And I got my bachelor's degree in aerospace engineering. And I realized that the more you know, the more you actually don't know. So I went to graduate school at the University of Washington up in Seattle, where I got my master's degree in aeronautics and astronautics. And then I decided to switch more to the scientific field. So I did my PhD in earth sciences and astrobiology. And astrobiology is the science of life in space. And so I came down to NASA Ames to do my postdoc doing that type of research. And then I found this amazing opportunity using my engineering degrees working with Fruit Fly Lab. So now I can do both my science and my engineering, grouping my passion about life in space. I essentially have my dream job today.
So, Sanjoy, that was really great learning about your background. Now, is there any advice that you can give to the high school students to help them enter into an engineering career field?
I would say the most important is follow your passion. If you're passionate about the engineering field, even if in high school you have some doubts about if you can do it or not, just do it, because passion will drive you to a point where you can excel. I was not very good at math and physics, but in engineering school I did it so much that you just become good at it. It's a natural process of learning. So stay curious, read a lot of books, and then if you can, even connect with scientists. You know, NASA scientists and engineers are happy to answer questions by email. So if you're passionate about Fruit Fly Lab, for example, check us out on nasa.gov, and then find a mission and email us, and we'll be more than happy to answer your questions.
Okay, well, what kind of great advice would you have for students who actually want to come and work at NASA?
That step is usually done in college, and so the advice I would give is that in addition to focusing on your academic credentials, meet your peers, meet your colleagues, connect with your professional societies, meet with people who are more advanced than you and get mentors. Look at internships. Internships is the best way to get into NASA early in your career. That's where you get to meet the scientists, that's where you get to meet the engineers, and with these connections you can then build to end up at NASA, because those scientists and engineers you work with, that will end up in recommendation letters for graduate school and so on. So it's a process where not only your academic skills are important, but also your personal skills are important. And internships is the best way to promote both.
Wow, that's really great advice for getting the students started out here at NASA.
You bet. I look forward to seeing you all.
So if you liked working on this engineering project and want to pursue an engineering career, check out some of the NASA design challenges that we have available. Also, if you liked learning about the Fruit Fly experiment, check us out on www.nasa.gov.